Hello everyone! In this video you will learn about two families of clustering methods, namely distribution clustering and connectivity clustering. Together we will see how clustering can be performed to obtain clusters based on distribution and connectivity. After watching this video you will be able to explain the technique of distribution-based clustering and connectivity-based clustering. There are mainly four families of clustering methods. They are clustering based on centroids, density, distribution, connectivity. This video will cover the later two families. First, let's find out what is distribution clustering. Distribution clustering is performed by calculating the probability of a sample belonging to a cluster. It assumes that every sample has a different probability associated with all the clusters. If we consider a centroid of a cluster, the probability of the centroid belonging to the cluster will be 1. The farther away the sample is from this centroid, the lower the probability will be for the sample to be in the same cluster. In this plot, you see an example. When the sample is near the centroid of a cluster, the probability indicated by the thickness of the line is very high. The farther away, the lower the probability a sample has. For another centroid, shown in red color, you can see similar curves for another cluster. The same pattern of probability also applies here. Then, distribution clustering determines that a sample goes to a cluster with the highest probability. You might have to deal with some issues when using this family of clustering methods. If you have samples that are exactly in the middle of two clusters, you need to decide whether the sample belongs to one cluster or the other. Also, if a sample is in the outlier far away from all clusters, then the sample does not belong to any cluster with a high probability. So you may take out the outliers or consider increasing the number of clusters. Next, let's learn about the idea of connectivity clustering. Connectivity clustering starts with individual clusters. It means each data sample is its own cluster. In the plot on the right, you see every data sample is its own cluster represented by a unique color. Then we find out how similar the data sample is to the other samples. In other words, it discovers connectivities between the sample or initial clusters. Then we merge the samples that are within a distance of each other into new clusters, like the 4 clusters indicated by the ellipses. Next, we start increasing the distance between samples, and here we get 2 more clusters that are larger than the previous ones. By keeping increasing the distance, we will create more and more clusters until the moment when the whole data set will belong to one large cluster. Using the discovered connectivity among the data samples, connectivity clustering can determine the final clusters when we choose a maximum distance we want the samples to have within the clusters. In this video, we first learned distribution clustering is performed by calculating the probability of a sample belonging to a cluster. And 2 possible issues for distribution clusterings are when a sample shares the same probability or similar probability with 2 or more clusters, or when a sample is an outlier to the existing clusters. Then we learn about connectivity clustering that discovers connectivity among all data samples by continuously merging similar samples into clusters. And the resulting clusters of connectivity clustering depends on a choice of similarity.